when you're doing a piecewise defined function, the best thing that you can do is find the important points first. Before you start drawing your graph, let's find the points that are important to that particular graph. So you want those points for each piece. So when I look at the first piece, the negative 2x, it happens for all x's that are less than 1. So that means we need to find what's happening at 1. Where is that at? So what I do is I find the important point by plugging 1 in for x and find the y value that's going with that. Okay, 1 times 2 would be, or negative 2 would be negative 2, right? So that's an important point. So this is an important point. Okay, so I like to do one piece and then go back and do the other piece. So that's what I'm going to do. I'm going to draw the graph here for that first piece. So that important point is at 1, negative 2. So I'm gonna go to that spot, and then we have to answer the question: is that point included in the graph? Well, look at your inequality. That's what tells you if it's included or not. It's just a straight less than symbol. Does that mean included or not included? All right, awesome. What would be included? If something is included, it means it has to be able to be equal to that, right? Is that equal to? No, so it's not included, okay? So 1, negative 2 is an empty circle. Okay, so we've got this point. It's an important point, but it's an empty circle. Now, here's what we got to think about. What x values does negative 2x work with? Works for all x values that are what? Less than 1. So which direction is that going to go? Left or right? Left. So I'm going to use the knowledge I have about linear pieces and say, okay, if it's going to go left, I know that that's the slope of negative 2. So I'm going to count my negative 2 slope to the left. So that would be up 2 and left 1. And I could do that a couple of times, 3 times maybe. And it keeps going forever to the left. Negative 2 slope, up and to the left, like that. And that's that first piece. Sydney? I did do that wrong, didn't I? Thanks for pointing that out. Because that would, there, should be there, and then go, thank you, Sydney. There we go. 1, negative 2, and then negative 2 slope. Thanks. And then we go from there. We're done with that. We arrow on the end because it says less than 1. It keeps going forever. Don't. There's a difference when there's a different inequality there. You got to pay attention to whether it keeps going forever or not. All right. Now let's move to the next part. The next piece is 3x plus 1, but it happens when x's are greater than or equal to 1. Okay, so where would the important point be? At 1. Well, if I plug 1 into the equation 3x plus 1, what do I get? 1 times 3 is 3 plus 1 is 4. So I get this important point at 1, 4. 2, 3, 4. And then, is it included or not? Why? Because it's got an equal to mark. So that's a filled in dot. Okay, so we're going to have some open circles. We're going to have some filled in circles for dots and points. And then what do I know about the line 3x plus 1? The y-intercept is 1, but do we even go to the y-intercept on this one? Why not? Because the x value for the y-intercept is 0, right? And our inequality doesn't include 0. It's all greater than 1. So So yeah, normally the y-intercept's 1, but that's not going to be part of our graph because our x values don't fit that. But we do know that the slope is what? 3. So we could continue this graph which direction? To the right, because it's greater than 1, up 3 over 1 a couple of times. And we get the graph of that piecewise defined function. Those two pieces. So it's basically like systems of equations. You're graphing 2 lines, but you're not graphing all of both lines. And we're going to mix in some absolute value with that too. But you're not. One thing, we're going to see this as we go. These numbers here won't always match, be the same number. They are a lot of times with piecewise, but they don't always. They don't have to be. There's no rule that says they have to be. Okay. Let's look at this one. G of x, piecewise defined function with 2 absolute value of x for all x's that are less than 0, and then just a -5 for x's that are greater than or equal to 0. So what's the important point for the first piece, the absolute value piece? What's the x value for that? It'd be 0, right? And then if I plug that in, what's the absolute value of 0? 0 times 2 would be 0. The origin is an important point for that graph. It's also an important point for that graph because it's an absolute value graph. What's the vertex of that absolute value equation? It's 0, 0. So I'm going to go to 0, 0. Would I put an open circle or a filled in dot? Why open, Sabrina? Yeah, it doesn't have the equal to mark, so it's an open circle on the origin. And which direction am I going to count the slope? We know it's an absolute value graph, so it should make a V shape, but we got to base what we do on that inequality. And so it says x's that are less than 0. So I'm going to go which direction, left or right? Left. And how do I count that? Since it's absolute value. What's this 2 in the front? It's the slope of the line on each side, right? So if we're going to the right, it would be up 2 and over 1, but we're not. We're going to the left, so it's up to left 1 because it's absolute value graph. And it keeps going forever in that direction. Get that piece. Now, the second piece is y equals -5. What do we know that looks like? We were just going to graph y equals -5. The horizontal line at -5 on the y-axis, right? Where does it start at for this problem? At 0, because that's the first x value that part has. So that part says, oh, an important point is at 0, -5. Okay? So I'm going to go to 0, -5. Put a filled in dot. Why did I put a filled in dot, not an open circle? Equal to symbol. There doesn't always have to be an equal to symbol on one of them or anything. It just depends on the problem, what they give you. And we're going to go a horizontal line in which direction? Right. To the right, because it's greater than. That's exactly right. Keeps going forever. And we've graphed a piecewise defined function that had an absolute value piece. It doesn't really look like it is because we didn't get the V shape, but that doesn't mean it's not it is that half of the absolute value graph. We're going to see some in just a second that you get more of that shape. All right. look at this one. And say we had f of x equals, let's say we had absolute value of x plus three minus 2 is less than or equal to x is less than or equal to negative 2. And then let's do negative x minus 2 for negative 2 less than x less than or equal to positive 1. And then let's do 3/4 x for x's that are greater than or equal to, or greater than, let's do greater than 1. To get 3 pieces on this one. Yeehaw. Okay. So again, the best thing to do is just take one piece at a time. Don't try to do it all at once. Just take one piece at a time and figure it out. So what's the first point that, or the important point for the first piece? Well, the x value would be what? Negative 2, right? What's the y value at negative 2? So if I plug in negative 2, that'd be 1. The absolute value of 1 is 1. 1 minus 2 is negative 1. So there's an important point for that graph, is at negative 2, negative 1. So I'm going to draw my coordinate plane. I got 3 pieces, so I'm going to draw this one just a little bit bigger because I feel like it may need to be. Okay. And I'm going to go to that point, negative 2, negative 1. Do I put a filled-in dot or open circle? Filled in this time because it's equal to, right? So negative 2, negative 1. And then what do I know about the absolute value graph of x, absolute value of x plus 3 minus 2? Where's the vertex for that? You should know this. You just did this. No. Say it again, Jay. Negative 3, negative 2. Negative 3, negative 2. So is that to the left of negative 2? Is negative 3, negative 2 to the left of negative 2? It is. So that means that's going to be part of my graph. So that's what I kind of try to pull on there is, okay, that point, there's the vertex right there. Negative 3, negative 2. And then what happens at that vertex? It's going to turn directions, right? It's going to make the V shape. Okay? So this little piece right here is the right-hand side of the V. It's just a really short, small piece right there. And then the left-hand side of the V is going to go up 1, left 1. Why is it going up 1, left 1? Not necessarily. Look at the equation. What's in front of the absolute value? 1, right? So if there's a 1 there, that means that's the slopes going up 1, left 1, up 1, right 1, right? Okay, so we get more of an absolute value looking piece right here, and that's good. Okay. Now, let's go to the second piece. Look at your inequality. How many x values are on it? There's 2 of them, right? So that means this has got n pieces. It's got two important points. The first important point would be at x being negative 2. What's the y value when x is negative 2? I'm going to do a different color for this one. Red. Negative 2. If I plug negative 2 into the equation. Yeah, I know. we can still talk. If I plug -2 into -x minus 2, what's the y value? -2 would be +2, -2 would be 0. So -2, 0 is an important point. What's the other important point? I know you can't see it. It'll be okay. Get it up there in just a second. Would be at x equals 1. What's the y value when x equals 1? When x equals 1, -3. I can look at you, just tell him always call a life and tell him that he died doing what he loves. Dealing with Apple TV, not working with a PC. Yeah, they don't work. All right. So you got +1 and then -3. So those are, what do we know? Which one of those is included in that? The -2, 0, or the 1, -3? One is included and one is not. Which one is? The 1, -3. Why is the 1, -3 included? Because it has an equal to mark. All right, come on, Apple TV, show up. And you're wondering, why is he not just plugged in the VGA cable? Because it doesn't work either. Da, 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 da. And we're back in business. All right, so at -2, 0, we're going to put an open circle. -2, 0, right there, open circle. That was a little bigger than I intended. There, that's better. And then at 1, -3, filled in. What do we know is going on in between there? Is it a crooked line? Is it a straight line? And why? Well, what's the equation? It's -x minus 2. What kind of equation is that? What form is it in? It's in slope-intercept form, so that means it has to be what kind? Straight line, linear. Okay, so that's a linear piece. So it's a straight line. Got to be able to recognize those things. Here's the thing, guys. If it ain't an absolute value, it's linear, because that's what's on our stuff. That's what we're talking about. As we go forward through class, we're going to bring back piecewise, and we're going to add in quadratics. We're going to add in cubics, that sort of thing. So it's going to happen. All right. So we've got that piece done. Hey, piece number 2. Great. Go to piece number 3. What's the important point for piece number 3? 1 and 3/4. Yeah. Plug in 1 for x, work it out. 3/4 times x, 3/4 times 1 is 3/4. So I'm going to go to 1 and 3/4. Do I fill in that circle or open? Open. It's not equal to. So I'm just going to kind of guesstimate where 3/4 is and put an open circle. That's an open circle. And then what do I do next? What kind of equation is this? Linear or absolute value? Linear. So that means it's got a slope. So what's the slope? 3/4. Which way is it going? To the right or to the left? To the right, because its x's are greater than 1. So we're going to go up 3 over 4. 1, 2, 3 over 1, 2, 3, 4. Put a dot. I'm going to do it again. And there we have that piece graphed. It's not something, it's each piece individually is not that bad. It's just you're not used to doing the part of a graph. You're so used to doing the whole graph for everything you do. You got to do parts of things here and build up to things. All right. Let's look at this one. Try to get a good one that does a good bit of fancy stuff. Example D. Yeah. Fourth example. Let's say we had negative or f of x equals negative x minus 2, negative 3, and then negative 2x plus 3 are our pieces. Let's do this one for x is less than negative 4. This piece for, let's do negative 2 less than x less than or equal to 3. And let's do this one for x's that are greater than or equal to 4. And again, the x values don't have to overlap every time on the inequalities. This one's going to have some gaps in it. And that's okay. Don't think that they have to match up every time. That's not what always happens. But the process you're going through is always the same. So we're going to start with the top one. What's the ordered pair that's important for that piece? Negative 4. Positive 2. Good. So we know if we go to negative 4 and positive 2, we're going to put what? Open circle, filled in dot. Open circle. Negative 4, positive 2, open circle. And then we're going to the left of that because it said x's are less than negative 4. So the slope of that line is what? Negative 1. So I'm going to go up 1, left 1. Up 1, left 1. I know that that's a negative slope if it's doing that. Okay. Let's get to that open circle. So there's the first piece. Good to go. Okay. Piece number 2. What do we know that graph looks like? Y equals negative 3. You know it looks like what? Horizontal line, right? Where does that horizontal line start? At negative 2, negative 3. Where does it end? At x value, same y value. Y value is not changing when it's constant like that. We'll have a slope to change the y value with. Okay? So, which one's open and which one's closed?
First one's open.
Okay, so negative 2, negative 3 is open. 3, negative 3 is closed. And we know it's a horizontal line. Straight across there. Line is not very straight. So try it again. That's as straight as I can get it. And what do we do on the next piece? Plug in 4. Good, good. That's right, JP. Plug in 4. 4 times negative 2 is negative 8 plus 3 would be negative 5. So we're going to go to 4, negative 5. 1, 2, 3, 4, 5. There we go. Oop, I filled it in, but should I?
Yeah.
Yeah. Why yes? It's equal to. It's got the greater than or equal to. Now, which direction am I going to go when I count my slope?
To the right.
To the right because it's greater than. Greater thans go to the right. So down 2 over 1. I could continue that if I needed to. I'm out of space. But go ahead, JP. What's that? Like on the left side? What do you mean? Well, this one's going down. Like this piece right here is pointing down and to the right because the slope is -2. On the left-hand side, like this side, the arrow should be on the out going that way. And they may be pointing down, but it's always going that way on that. And it all depends on that inequality that's out there beside it. And they put them in order like left to right when they do the inequalities. Okay, maybe we're getting a little bit better at this. That was a good one. Y'all did much better. So let's try another. Throw this one at you here. G of x. Here's our pieces. +4 for x's that are less than or equal to -3. And this is the curveball. Absolute value of x over 2 from -3 to 1. And then let's do x plus 2 for x is greater than or equal to 1. So the inequalities overlap on this one, but still same process. So first piece, -3 is the x, 4 is the y. Not any work to do on that, really. You just match up the ordered pair. Okay? I can go draw. We'll kind of scroll back and forth here. So -3, +4. Open or filled in? Filled in. What's the graph look like, and what direction does it go? Horizontal to the left, right? Because it's less than. All right, that middle piece. That's the one that's the curveball. Dividing the absolute value by 2, one thing you've got to remember here, and you know, absolute value of x over 2 is the same thing as 1/2 absolute value of x. Those are exactly the same thing. They're going to write it like this most of the time if there's nothing else going on. So that's kind of a notation type thing, to understand that this, that right there is the same thing as having a 1/2 in the front. If it was absolute value of x over 3, it's like 1/3 in the front. Okay, so keep that in mind, that it makes it much simpler and it fits into what we know about absolute value graphs. Okay, important points. Yeehaw. -3. What's the y value? 3/2. 1. 1/2. -3. 3/2 would be right there. Is that an open or a filled in circle? Open. Okay, and then the other one is at 1/2. Open or filled in? Open. What do we know about the vertex of absolute value of x over 2? Because it's an absolute value graph, we need to think about vertex. What's the vertex? Anybody? Well, there's no H and there's no K. If they're not there, the vertex will be 0, 0. And then that makes it easy to draw the graph because it's a V that does that. So you get a lot of the, more of the left-hand side of the V than you do right-hand side. You get that. You get a little bit of the V shape there for the absolute value graph. So one thing you're going to realize with Algebra 2, and I'm not trying to scare you or anything, that everything we do is used in the next thing we do. Okay? So don't forget the things you're supposed to know about absolute value graphs and the things you're supposed to know about linear graphs and all that stuff. We're going to use it. Okay? What's the important point for part number 3? One, 3. So I'm going to go to 1, 3. Open or filled in? Okay. What kind of graph is x plus 2? Linear. Okay. So if it's a linear graph, that means it's got a slope. What's the slope? 1. Which direction am I going to count that? Right. Up 1 over 1. Keeps going. It's like 3 separate graphs, but like just small windows of them is what we're trying to build here. The separate graphs with just small windows of each piece. Okay. So the graph is the answer on this stuff. This is going to take some practice. So I've got some practice for you here. This will be your homework set for this section. So on this, you got several problems. You got about 10 minutes left in class today to work, but it's just what we've done here. Some of them have a couple of absolute value pieces. Most of them have one absolute value piece and then a linear piece, a couple of linear pieces maybe. It's just mixed up, all kinds of different things, but it's only linear and absolute value stuff. Okay, if you'll go through that process that we just went through, you're going to, do it correctly. Okay, if you'll go through, get the important points, and go from there. All right. So there are 24 graphs here. The grid's already there. Be careful to pay attention to the grid, the scale on the grid. They didn't mark each individual thing as one, but that's what it is. I think every one of these goes from -8 to +8 in both directions. So they should fit on here. If you get something that's not fitting, then you probably are not, you miscalculated something. Okay, so they should all fit on the graph that's provided there. Okay, so working on that stuff and trying to figure this stuff out.